So we have these AIs, right? They can write poetry, they can explain quantum physics, they're brilliant. But what happens when they're brilliantly wrong? Today, we're digging into the quest to build an AI that isn't just smart, but one that's actually honest.
Okay, just imagine this for a second. You ask a super powerful AI about the moon landing, and it spits back that. I mean, it's totally absurd, right? But this is a perfect, if hilarious, example of what researchers are calling an AI hallucination. It's when an AI just makes stuff up and says it with total confidence.
And that right there, that's the central mystery we're trying to crack open. How can these things be so smart, writing poetry, debugging code, explaining physics, but at the same time invent facts like they were there? To figure this out, we've got to go deep inside the machine and really understand why these brilliant AIs are, well, such confident liars.
All right, so to get to the bottom of this, we first have to wrap our heads around what these hallucinations really are. And here's the kicker. It's not just some simple bug you can patch. It's something much deeper, baked right into the way these models are designed.
So here's the thing you have to get. A large language model, an LLM, is basically a master of language. Its whole job, its entire reason for being, is to predict the next most likely word in a sentence. It's amazing at spotting patterns, mimicking style, and understanding grammar. But, and this is a huge but, it doesn't actually learn what's true. It doesn't get logic or cause and effect. Think of it as the world's best pattern matcher, not a truth seeker.
Yeah, this table really lays it all out. See, current AIs are all about prediction. Their goal is to find the path of least surprise, the most probable string of words to get from your question to an answer. But this new idea flips the script. It's not about what's probable, it's about what's viable. It's about finding the path that is the most structurally sound, the one that doesn't contradict itself. The big flaw with the old way? It can connect literally any two ideas if there's a statistical link, even if the result is complete nonsense.
And that flaw? It leads us right to the heart of the diagnosis in the paper we're looking at. They have a great name for it, the flatness problem. And honestly, it's a fantastic way to picture what's really going on under the hood. Okay, stick with me here. Picture all of human knowledge as a giant map. For an LLM today, that map is totally, completely flat. Every single concept is just a dot on a huge, featureless piece of paper. Neil Armstrong is a dot over here, and giant turtle is a dot over there. And because the map is flat, the AI sees a perfectly valid path between them. There's nothing in its world like a mountain of truth or a canyon of contradiction to block the way.
And that is the core of the problem. In the real world, there should be a grand canyon of logic separating the moon landing from banjo-playing turtles. But since the AI's map is flat, it feels like it has to connect the dots. So what does it do? It builds this flimsy little bridge made of plausible-sounding words connecting two points that have no business being connected. That bridge, that's the hallucination.
This leads to a really powerful way of redefining what a hallucination is. It's not just a random mistake. The paper calls it the forced continuity of a discontinuous reality. Let that sink in. The AI isn't failing. It's actually succeeding at its job, which is to create a smooth path. The problem is, it thinks reality is smooth and continuous when, it's not.
Okay, so if a flat map is the problem, what's the solution? Well, you give the map some hills and valleys. Let's dive into how building a map with some actual topography could lead to a whole new kind of AI.
That's exactly it. The whole idea is to add topography to this map of meaning. We start building in hard, structural rules that create what you could call canyons of contradiction. A statement like A and not A isn't just a tough road anymore. It's an impossible chasm the AI literally cannot cross. And facts, they become like solid mountains that you can't just ignore or walk through.
So how do you even measure a landscape like this? Well, the paper proposes something we can call a contradiction score. The best way to think about it is like a stress test for an idea. Every time the AI comes up with a thought, the system runs the numbers and spits out a single score. If the thought is totally logical and holds together, the score is 0. Perfect. But if it's built on a shaky foundation of contradiction, that score shoots way up. It's a mathematical alarm bell for bad arguments. And this score gets calculated in this really cool 4-step process. First up is emergence. That's basically the AI just brainstorming a bunch of possible answers. Then comes memory, where it's like, okay, let's fact-check these ideas against what I already know. After that is propagation, where it tries to build a solid argument connecting the dots. And then the final and most important step, residue. This is where it actually calculates that contradiction score and measures the internal stress of the whole thought.
Now, this whole process isn't just happening on its own. It's managed by a totally new kind of architecture. And it's not a replacement for the LLM we already have. Think of it more like a really, really smart supervisor. It's called the topological inference engine.
So here's the play-by-play for how the tie works. Step 1, the normal LLM does its thing and spits out a few potential answers. But then, the tie steps in. It takes each of those answers and plots it on that 3D map of meaning we talked about. Then it runs the stress test on each one, getting that contradiction score. And for the final step, it just picks the one with the lowest score, the one that's the most structurally sound. Simple as that. So let's be super clear about this. The TII doesn't actually make the LLM any smarter. It makes it honest. It's kind of like having a logical System 2 brain that double-checks the fast, intuitive gut reactions of the LLM's System 1. Its whole job is to figure out the cost of coherence, to see if a thought actually holds together, no matter how good it sounds on the surface. And this is where it all comes together. This is the most profound, most exciting part of this whole idea. We're moving beyond just a clever bit of engineering and into something that really feels like a huge leap forward.
So this is the million-dollar question, right? What happens if the tie gets, say, 5 different answers from the LLM? It stress tests every single one, and they all fail. They all have a super high contradiction score. What does it do when there's just no good, structurally sound answer to be found?
The answer is kind of revolutionary. The system does something that AIs today just can't do. It stops. It just stops. The paper calls this the kenosis operator. It is quite simply the power to say, I don't know. Think about it. Current AIs are always forced to give you the least bad answer. But TI can actually recognize when no good answer exists and just stay quiet.
And that right there, that is the huge paradigm shift. An AI admitting its ignorance is no longer a bug, it's not a failure. In this model, it's the ultimate feature. It's a sign of integrity. This is, and I am not exaggerating here, potentially the birth of intellectual honesty in a machine. The moment an AI truly knows what it doesn't know.
So that leaves us with one last big question to chew on. For so long, we've measured machine intelligence by how well it can give us answers. But what if true synthetic cognition only really begins when a machine can start to doubt its own answers? You know, if an AI can check its own work and has the integrity to say nothing when an idea just doesn't hold up, well, that kind of forces us to rethink what it even means to think in the first place.